Hello, everybody, and welcome to this EDA Summit presentation entitled Key Event Broker Capabilities for Operational and Analytical Use Cases. My name is Sean McAllister. I'm the Chief Technology Officer at Solace, and I'd like to thank you very much for joining me today. So let's jump into it. First, I'm going to define the difference between operational and analytics use cases so that you know what we're talking about here. So operational use cases are the ones that run your business. They're typically real-time, they're online and responsive in today's world. And examples of this might be payment processing, e-commerce applications, fulfillment applications. Analytics applications are the ones that seek to give you insights about your business. And they can also very much be real-time, they can be offline, or they can work on historical data. And examples there would be fraud detection, real-time recommendations, and fulfillment analysis. So, and if you take a look at the different colors here, I've been very clever and I color coded them because oftentimes operational applications work hand in hand with analytics applications. So the payments applications, for example, that use Solace event brokers all have fraud detection applications that work with them. The e-commerce applications where I'm surfing the website, looking at different products, putting things in my shopping cart, are sending events to the recommendations engine to be able to upsell me to other products that I might want to be interested in. And similarly, fulfillment analytics is receiving events from fulfillment systems to be able to help you better manage your end-to-end fulfillment process. And many of you have perhaps implemented systems like this, operational and analytic systems. Maybe you've done it with event broker technology, and you will have chosen a particular event broker, and hopefully you were very successful doing that. Now, as you move on to your next use case, and you think, hey, I'll just reuse the event broker that I have now because I've learned how to use it, and it's operationalized within my enterprise, so I'll just use that in my next use case. But you want to be careful that you don't fall prey to this. If all I have is a hammer, everything looks like a nail. Right? Different use cases have different requirements, and certainly different event brokers have different characteristics that make them more applicable for one use case versus another. So let me first talk about the different types of event brokers. And I'm going to split them up into two categories: the discrete event routing brokers, which are the ones that route discrete events to applications so that applications see exactly the types of events that they're interested in and no more. And as compared to the log-based event brokers that send streams of information to their client applications. And David Mutter, who is an analyst from Forrester, is also hosting an EDA Summit presentation, and he talks about these two types of brokers. He calls one the smart broker, hence the brain, and the other one the log stream brokers. And so, check out his presentation if you want more information on this. And as I talk about and explain the architectures and the values of each of these types of brokers, we look at the characteristics on the left. And if we start with, the genesis of where some of these brokers came from, for discrete event routing, some of these brokers have come from a more legacy messaging environment and have matured to become event brokers. Others, like Solace, come from a networking heritage. And so they inherently have capabilities like dynamic routing and WAN optimization, and they very much view event distribution as a network problem with network solutions. Log-based brokers, very heavily influenced by database technology. So they scale horizontally to add more storage. They have static replication between them. People use KSQL as an example to be able to create substreams within a stream. From a message exchange pattern point of view, the discrete event brokers very typically support multiple message exchange patterns like pub/sub, request/reply, point-to-point, and they support persistent and non-persistent qualities of service. Whereas the log-based brokers support pub/sub and have persistent messaging typically only as their only quality of service, as they store all their events to disk first. From a horizontal scaling point of view, you would scale discrete event brokers based on traffic volumes. So either message rate for small messages or bandwidth for large messages. And while you could scale log-based brokers for those reasons, people also very often scale log-based brokers purely based for storage, as they're used as an event store to store many months worth of events to be able to run analytics on them. And then finally, as a balance of brains, like, where's the intelligent processing happening in these architectures? In discrete event routing brokers, the broker is intelligent, and that's where a lot of the features are implemented in the broker. So you have a smart broker and simple clients, and the converse is true in log-based brokers, where the broker is very simple and the clients have more processing to do in order to fulfill their requirements. So with that in mind, now let's move to examining the two different types of use cases and the characteristics of those use cases. So on the left-hand side, I have a whole bunch of characteristics that I've put listed. And for each of the use cases, I've said whether that characteristic, yes, is required for that use case, or no, is not required. Maybe nice to have, but not really required. Or it depends, because it depends on the application per se, or becoming so, which I list because as applications evolve, I know we are seeing situations where functionality that was maybe very optional before is becoming much more in demand, and therefore we feel is going to become yeses over the next little while, where operational use cases will require this capabilities. Now, I'm going to talk about the top 4 in more detail, but because we don't have a lot of time, I'm just going to limit it to those 4, and I'm going to quickly go through the other ones below just to explain those. So from a stream partitioning point of view, what that means is the ability to take a stream of events and apply them to a horizontally scaled set of consumers. So you partition it to those consumers to be able to maintain order and processing. And so horizontal scaling is a requirement of both operational and analytics use cases. So that's done. Low latency, more important in operational use cases, or very important in operational use cases, because you need to be able to provide good user experience, fast response time to your customers. And any time that is spent processing events in the event broker is time that you don't spend for the application, or time that that you're not giving to the user back as a good experience. And whether that's important in analytics use cases depends. It's very important in fraud detection use cases, maybe not so important in fulfillment analytics, for example. Hybrid cloud, multi-cloud becoming much more important in operational use cases, because as systems of record on-prem get extended to the cloud for microservice operational processing, you need to be able to have a seamless way of doing that. Whereas with analytics systems, not so important. You bring the events into the central event store and you process them from there. Lossless delivery and resilience, always critical in operational use cases, because those use cases run your business, right? Now, and it depends in analytics. Again, in real-time recommendations would be very important, right? But if you're doing clickstream processing, not so important. Then finally, stream processing, replay, and event sourcing, critical requirements in analytic use cases, not so much so in operational, although we are seeing replay becoming very much in demand in order to recover from faults in operational systems. So let's dive into those top 4 characteristics and see how they apply to the 2 different use cases. So fine-grained filtering and routing with sequence. Very required, very important for operational use cases, not so much really for analytics use cases. What I mean by this characteristic is really the ability for an event broker to deliver to consumers just the event that consumer application wants, and not a whole bunch of events that need to be filtered. Why is that important for operational use cases? Well, it's because as you develop operational use cases in microservices, or even a monolith, but whose component wants to be triggered just on specific events, what you don't want to do is to be sending all order information to a microservice that only cares about new orders or canceled orders or shipped orders. It just wants to receive the events that it needs to process in order to be efficient. Similarly, for event-driven integration, if you're synchronizing master data management or customer information or employee information, you will have to steer that just to the applications that need certain types of updates, not all information to all consumers. And this is different than analytics use cases, where you want to bring in all that information to a central place and have fairly coarse distribution of that data, because analytics applications want to be able to process lots of information, or process more information in a month from now than they do today because of a change in their algorithm. So let's look at how this kind of discrete event routing would work with a streaming application, a streaming event broker like Kafka. So in this operational use case, what I want to do is I want to send new order events to the red client. I want to send cancels to the yellow, and I want to send shipped to the blue, for example. And the challenge with log-based architectures is that you can either have filtering or you can have in-order delivery, but you can't have both at the same time. So if you want filtering, you don't get in-order. If you want in-order, you can't do filtering. And the reason for that is because events from different topics get put into different log files in the broker. And so two events from two different topics are placed in two different log files, which means that an application who wants to consume both of them can't be guaranteed that they will be received in the order that they were produced. And what that means is that you design your architecture to have very coarse-grained topics. So like the orders topic, and all events related to orders go into that topic. And then each application then in turn filters for just the events that it wants, which means that if you're producing events from potentially many applications into the Kafka broker, and all those order events, new, canceled, shipped, need to be all sent to each application. They're filtered out in the application using K-streams or using something else. And then a very small, a much reduced subset is sent to the client application for application processing. And in some cases, you have events that are received by so many applications that you don't want all applications to receive all the events. And so there is a design pattern where you'd have, let's say, client 4 that consumes all of the orders events, filters just for new orders, and produces just the new order events on a new order topic. And those can then consumed by client number 5 and many other clients who want to receive just the new orders, not all of the orders. So you can kind of see in this case where, again, in operational use cases where you want more discrete routing of events, both of these alternatives, they're expensive because you have to distribute all this data over the network and all this processing. You have to horizontally scale your clients to consume the data and filter it. They can become complex if you add, client 4 filtering. The architecture becomes fragile. And then security becomes an issue because you cannot count on a client application to throw away data he's not allowed to receive. And therefore, you have to implement filtering like what client 4 does. The alternative in discrete event routed brokers is to use a paradigm where we advocate, for example, to use a taxonomy with your topics that have a noun, a verb, and an adjective or metadata. So you say, what is the object that's changed? What has happened? And give me some information about it. So what do I mean by that? Well, you can create topics that look like this, where you can say an order was created for ice cream. And here's some information about that ice cream. Or you can say that a payment was canceled and it happened to be a high value payment. Or you can say that Emirates had a boarding pass that was scanned, and here's some information about the boarding pass scan. So you annotate your event with this kind of metadata, noun, verb, and adjectives. And then you can create subscriptions to receive only the events that you want based on that metadata. And you can use wildcards like the asterisk that wildcards one particular level, or you can use the greater than sign to say any metadata following this in the topic. So, okay, how would you use that? Well, everybody's been on a plane, right? So let's say I have events related to flight status. So I'm going to emit events that have a taxonomy like in the upper left, where I say flight, here's the status, there's the flight number, the origin airport, the destination airport. So now when I'm publishing events, I can say, here's a flight that departed, and it's United 1070 from Newark to Chicago. Or there's a flight that has been delayed, and that's Delta Flight 2359 from JFK to O'Hare. Or a flight that is arrived at the gate for United 3441, which is from Columbus to O'Hare. And I publish this metadata into the event broker. And now I can have subscribers that say, I want to receive all flights headed to Chicago O'Hare. How do I do that? Well, I create a subscription that has flight, I wildcard the status, I wildcard the flight number, I wildcard the origin, but I say destination is ORD. Or all flights originating from JFK. So flight, wildcard status, and flight number, origin JFK, and any destination. But then what's really cool is I can do these kinds of more sophisticated filtering where I can look for United flights from JFK that have been delayed. So the way I do that is I say my subscription is flight delayed UA asterisk, so any flight number that starts with UA and whose origin is JFK. And the net result of that is that if you look at the top there, as you publish all these events into a Solace event broker, only the red, yellow, and blue events, or only the certain type of flight events, are sent to each consumer. And in contrast, if you have a log-based broker, then all flight information is sent to all consumers and needs to be filtered and then presented to the application. So in situations like operational situations, applications where you have software that is discretely responsible for particular functions and wants to be triggered off specific events, much more efficient to be able to discretely route events in a sophisticated way done by the broker. So now let's get into the next characteristic, which is rich application integration capabilities. And so by this, we mean having a rich set of software APIs in a whole bunch of different languages, supporting different standard protocols and having connectors. This is very important for operational use cases, not so important for analytics. Why is that? Well, so in operational use cases, you have legacy applications that run your business today. Maybe you have third-party applications. Many of those are third-party, like off-the-shelf applications. Many of those would use JMS or JCA APIs, so you want to support them. You're building new applications, so you want APIs or client libraries in more modern languages like JavaScript and Python, Node, Go, and you want to support serverless or function as a service. You want to support modern frameworks like Spring Cloud Streams and Dapper. And there's a session on Dapper if you want to go and take a look at that framework. You want to support standardized protocols like AMQP and REST or webhooks, because if you're interacting with your partners in an event-driven way, which is becoming more popular, you want your partner to be able to choose whatever client library they would like and interact over a standard protocol. You want WebSockets because you want to be able to push real-time updates to mobile apps or tablets or browsers. And you want MQTT because your IoT devices need to be part of your operational system because you need to command and control them as they're part of your business. They're not just devices that you gather telemetry from. And in analytics use cases, by far the most popular language to write analytics applications is in Python, or people use KSQL for stream processing. And they typically write applications in frameworks like Beam and Spark and Flink. And so you need connectors from your event broker into those environments. But then, primarily the processing gets done in those types of applications. But what you do need is a rich set of connectors, right? You need to connect into databases through JDBC or CDC. You need to connect into other messaging systems, specifically so that your operational systems can talk to your analytics systems. But different set of requirements in terms of the richness of application integration. Now let's get into messaging functionality, and whether that's required in operational use cases depends on the application, but it's typically not required in analytics use cases. So if you're building, again, a set of applications that need to interact with each other, they may need to send a request reply from one to the other. In some cases, of course, people will use REST for that. But if you don't have a RESTful environment set up and you have messaging and you can easily send a message and get a response or do asynchronous request reply, it can be very, very convenient to be able to do that. And then because the state that you're receiving is not just something that you process and run an algorithm on, you need in some cases to massage it and push it down to a next system behind you in an operational environment. There can be situations where you can't process this message right away. So you want it to be resent to you later without you having to do the work. So you want the broker to implement delayed delivery, right? You want the broker that if a message is being sent to an application, crashing that application, that you have a maximum number of redelivery attempts. And if that doesn't work, you put the event into the dead message queue for exception processing. In some cases, you want time to live because a message needs to be processed within a certain time or different action needs to be taken. Transactions important, XA or distributed transactions important for legacy applications, and session-based transactions important for microservices where you receive an event, do some processing, publish an event, and then acknowledge the one that you received, and then commit that as one transaction. Very common. And then in situations where you're doing real-time processing and your consumer could be overloaded, then message priority and delivering messages in priority order can be very useful as well. All of these things, as well as push delivery to be able to support reactive multi-threading, are all things that in an operational environment, as applications communicate with each other and you need to deal with this state in a very reliable way, it's much better if the infrastructure could provide that for you as opposed to you having to implement it around, in your own application. And these types of concerns tend to be not so much so for analytics applications, right? So you don't have a distributed complex choreography of applications that interact with each other. And instead, more what you need are things like long-term storage, where you can have events stored for many, many months, right? Many, many terabytes of data with replay capabilities. And so it's more that kind of a long-term access to data that analytics applications require, as opposed to more sophisticated ways of communicating amongst each other. So the last one that I'm going to get into, the last characteristic, is observability or distributed tracing. Now, in the days when people built monolithic applications, you could use logging and you could see, how from a single set of logs, how different application modules would call each other and how long things would take, where errors would happen, etc. But as people move to distributed systems, especially in operational systems where you're breaking up your monolith into distributed microservices, logging just doesn't cut it anymore, right? You can't look at a single log, you have to look at many logs. And so what you really want to be able to have is end-to-end tracing across your entire architecture through all components of your architecture. And more people are adopting OpenTelemetry as the de facto standard to be able to do this. And in a distributed architecture, as you often see in operational use cases, and you want to be able to do troubleshooting, you want to be able to monitor and look for performance bottlenecks, you need this kind of end-to-end tracing throughout. And especially for some operational use cases, if you're in a regulated environment where you need to demonstrate data sovereignty or provide proof of data governance, it's much better if you have the ability through tracing to be able to say, this is where the data went, and I can explicitly prove that. In analytics use cases, again, you bring on the data into an analytics processing engine or a framework, and you process it from there. So again, you don't have the interactions among applications outside of the framework that would necessitate this kind of distributed tracing as much. So if I go back to visually showing an example of an operational and analytics use case being used together, let's go back to a fulfillment situation where I press checkout and I have operational microservices on the top there, right? So I process the payment, and then I check my inventory, I do bundling. So I take all the things in the order and I decide which fulfillment centers fill which, and then I do picking of the bundle and packaging and shipping. And these applications all work together and send events that the customer loyalty application can watch for to keep the client up to date on what's happening. And these events also then go into the fulfillment analytics system. And then if you kind of go, okay, in this much more distributed environment, how do I troubleshoot problems? How do I find performance bottlenecks? How do I verify that the choreography that I've designed is actually what's happening? And many of our clients, what they've done is they've instrumented their applications to emit OpenTelemetry logging and tracing into this centralized dashboard so that they can see what's happening across all the different applications. And that's pretty good, right? That gets you a big step forward. But the thing is, there's this big black box in the middle here, right? Over your event broker, where you can't see as events come in and out of the broker. And so when you get an application that says, I'm not receiving certain types of events, how do you know that they're published or not? How do you know that they were routed to that application? Or maybe the application did receive them, but didn't process them properly. And if I have 5 hops in the processing of an event, how do I know if the end-to-end application time, response time is slow, how do I know which component is slow? And this is where adding a distributed tracing directly from the event broker to complement the tracing happening in your applications can be such a game changer. So now you can see from the event broker each message that was published, who published it and when, where it was enqueued, when it was transmitted, whether the consumer acknowledged it or sent back a knack. You can see how long it spent in a queue, how long the processing was. You have great visibility to add to the rest of your application telemetry to be able to manage your overall environment. So these are the things that I was going to talk about today. Many characteristics across these different use cases. But as I say, I think fundamentally understanding the requirements of your application and knowing that operational applications have different requirements than analytics applications, and therefore that not the same broker should be used for each one. So choose the right tool for your job. Careful with the guy with the screwdriver there. That looks painful if you use the wrong tool there. But yeah, take a look at the requirements of your individual applications, match that up to what each event broker is good at, and choose the right tool. So thank you very much for attending, and I hope you have a great rest of the EDA Summit. Thank you.